My dear friends, in my previous video, I introduced the topic invertible matrices. Invertible matrices, that means we can find the inverse of a matrix. That means if a matrix and its inverse are of same order, and if they multiplied, we will get identity matrix. That is the definition of invertible matrix. Therefore, suppose A is a matrix and B is its inverse, then AB equal to identity. That is the definition which you have seen in the previous video. A is any square matrix of order M and B is a square matrix of same order M. If the product AB gives you the identity of same order M, then B is called inverse of the matrix A and it is denoted by B is denoted by A inverse. If it is the case A is invertible, that is the definition of A inverse of a matrix. That means a matrix and its inverse, after multiplying, we will get the identity matrix of same order. That is the definition we have seen in the previous video, and also we derived some two theorems on invertible matrices. That is, theorem 1 states that uniqueness of inverse of a matrix. That means the inverse of a matrix is unique. A matrix has a unique inverse. That is the first theorem. And the second theorem is, if A and B are invertible matrices, then AB inverse is equal to B inverse into A inverse. That's also derived. That is the theorem 2 we have derived in the previous video. AB, the product of AB inverse is equal to B inverse, A inverse. That means product AB, the whole inverse is B inverse into A inverse. That we have proved in the previous video. Now, in this video, we are going to find out inverse of matrix by elementary operations. Inverse of a matrix by elementary operations. That is the topic we have seen in this, we will see in this video. Inverse of a matrix. Inverse of a matrix by elementary operations. Elementary operations. Inverse of a matrix by elementary operations. That is exercise 3.4. That is the lesson we are going to see in this video. Exercise 3.4. The problems in the exercise 3.4 are solved using the elementary operations for finding the inverse of a matrix. We know the elementary operations. There are 3 operations on rows and 3 operations on columns. You have seen that is, any 2 rows and columns are interchanged. R1 is interchanged to R2 and R2 in turn interchanged to R1. Or column 2 and column 3 are interchangeable. Any 2 rows or columns are interchanged. That is rule 1. And any row can be multiplied by a non-zero number. Similarly, any column can be multiplied by a non-zero number. That is second rule. And third operation, third transformation is the elements of any row or column are added with the corresponding elements of some other row multiplied by a unknown real number. Similarly, any column, the elements of any column are added with the corresponding elements of any other column by multiplying a non-zero real number. That is there are 3 sets of rules under row and 3 sets of rules under column, and totally 6 transformations we have seen in the previous video. Using these transformations, we are going to solve the exercise problems 3.4. That is, we have to find out the inverse of the given matrix using these transformations. We have to use either row transformation or column transformation for solving the problems. You are not supposed to do both the rows and column operations together in a single problem. If you follow either row operation or column operation, you should not mingle the row operation, column operations in a single problem. Okay. Now, let us solve the problem in the exercise 3.4. Find the inverse of a matrix and find the inverse of a matrix. Exercise 3.4, problem number 1. Find the inverse of a matrix 1, minus 1, 2, 3. This is a matrix. You find out the inverse of this matrix. See, you know by definition, any matrix and its inverse of, if you multiply, you will get the identity matrix of same order. I have already told in the definition. A into B is I, if B is the inverse matrix. So that is denoted by A inverse. Similarly, a matrix A and its inverse, after multiplication, you will get the identity matrix of same order. Or otherwise, identity matrix, the matrix, also you can consider the matrix A by multiplication of identity and the matrix. Any matrix with the multiplication of identity gives you the matrix itself. It is also another rule. Any number multiplied by the multiplicative identity, you will get the same number. 1 into 4 is 4. See, like that, in the matrix multiplication, the identity matrix with some other matrix gives you the same matrix C. So using this idea, we are going to solve this problem. Okay, you consider this by matrix A. You know A equal to IA. A equal to IA. What is A? 1, minus 1, 2, 3. This is A equal to I of same order. 1, 0, 0, 1 into the matrix A. A into I is A itself. Now, operating either row operation or column operations both sides, you will convert this identity matrix into inverse of A. For that, every problem, before solving the problem, you first see the first element is 1, because for identity matrix, the first row, first column element is 1. Here also already there is 1. If you are not finding 1 here, you have to bring that 1 after applying the row or column operations. You make it the first row, first column element by 1. It is already in 1, is 1. Therefore, we are not operating any other operation to get 1 here. Already the problem itself is 1. Okay. Now, column operation. If you add C2 with the C1, C2 becomes C2 plus C1. I am going to operate the column C2, that is C2 plus C1. Column C2, adding with the corresponding elements of C1. 1, 2. The first column will not alter. The second column is altered by adding column 1. Minus 1 plus 1, 0. 2, C2, 3 plus 2, 5. I repeat, the column 2 elements are adding with the column 1 element, and the answer should be expressed in column 2. Column 2 arrived by adding column 2 elements with column 1 elements. Column 2 elements after adding column elements, minus 1 plus 1, 0, 3 plus 2, 5, and that should be the column 2, the new column. That is again, similarly you have to operate the same operation, the identity also. 1, 0 you will not alter. Second column elements with the first column element, corresponding second column. 0 plus 1 is 1. 1 plus 0 is 1. Like that, you want to alter. See, 1, 0 you get. So you convert this left hand side matrix, A matrix, into identity matrix. So already 1, 0, we have 1, 0. So you will get 1 here and 0 here. For that, you subtract column 2. Okay. Next operation, you divide column 1 by 5. Column 2 by 5. Second column element you have to divide by 5. Then only you will get 1 here because we want 1 here. Therefore, you divide by 5 with 5, you will get 1 here. Therefore, column 2 becomes, by dividing the elements of column 2 by 5. So, first column you will not alter. 0 by 5 is 0. 5 by 5 is 1. Similarly, on the right hand side, first column we will not alter. 1 by 5, second column elements are divided by 1 by 5 and 1 by 5 into the same A. See, 1, 0, 0, 1. We make it to 2, the second or first column element 2 by 0. For that, you multiply C2 by 2. C2 by 2 and subtract C1. That is, C1 is you derive C1 by multiplying C1 minus 2C2. You multiply columns of C2 by 2 and subtract from C1. What do you get? First column C2, C1 is 1, C2 is 0, 2 into 0, 0, 1 minus 0 is 1. Second column element 2, C1 is 2 and multiply second column element 1 by 2, 2 minus 2. See, column operation means you first column element you keep as it is, second column element you multiply by 2, 2 into 0, 0, C1 minus 0, 1, 1 minus. Similarly, multiply by 2, 2 minus 2, 0. Okay? And the second column you will not have. So, it will become identity on left hand side 1, 0, 0, 1. Similar operation you will get. Multiply column 1 element as you keep C1 by as it is and multiply C2 by 2. 1 minus 2 by 5. 1 by 5 into 2 is 2 by 5. You will get 1 minus 2 by 5. Similarly, 0 into 2 by 5. 1 minus 2 by 0 into 2 into C2 is minus 2 into C2 is minus 2 by 5. And second column as it is, you will get 1 by 5, 1 by 5 into A. So, I will erase here. See, 1, left hand side is identity 1, 0, 0, 1, identity I equal to here 1 minus 2 by 5, 5, 1 is 5, 5 minus 2. LCM on taking 5, 5 in 1 is 5, 5 minus 2 is 3 by 5, 1 by 5. Similarly, 0 minus 2 by 5 is minus 2 by 5 and 1 by 5 into A. So, I equal to A inverse into A is the rule. I equal to A inverse into A. A into A inverse equal to I or A inverse into A is also I. So, A inverse into A equal to I, this is I of same order. Therefore, the element 3 by 5, 1 by 5, minus 2 by 5, 1 by 5, the matrix is inverse of A. This is the matrix of inverse of A. Therefore, A inverse equal to problem over. Therefore, inverse of A is, we determined what is that A inverse. Therefore, A inverse of given A is 3 by 5, 1 by 5, minus 2 by 5, 1 by 5. That is your answer. 3 by 5, 1 by 5, minus 2 by 1 by 5. This is your A inverse of the given matrix A. That's all about the problem. Similarly, we will solve one more. Here, we are using column operations in this problem. Next, I am going to solve one problem using row operations. Okay? We will see the problem. Third problem in the exercise we will see. See, if you what are all the operations you operate on left hand side, the same thing you should be carry out on the right hand side also. Find out the inverse of a matrix A. In the exercise 3.4, you are going to solve the third problem. Exercise 3.4. Find the inverse of, the third problem is 1, 3, 2, 7. A equal to 1, 3, 2, 7. It is a given matrix. You have to find out the inverse of A. We know by the result I equal to A inverse into A, you know. Also, A equal to, by rule, IA. A equal to IA. What is I? A is 1, 3, 2, 7. This is A. I 1, 0, 0, 1. The identity of order 2. And A, I in A is A. The first row, first column element is already 1. There is nothing to operate on the first element. That is already 1. You are having 1. Now, row operations you will see. R2 minus 2. I am going to operate R2 by subtracting R2 by 2R. R2, I subtract elements of R2 by 2R1, 2 into R1. That is, the elements of R1 are multiplied by 2. First row, 1, 3 it is not affected because we are operating second row. R2 minus 2R1, this is R1. 2 into R1 is 2, 1 into 2 into 1 is 2, 2 minus 2, 0. And 7 R2 multiplied by 2. 2 into 3, 6. 7 minus 6, 1. Simple. Similarly, 1, 0, you will not affect the first row. Second row, R2 minus 2R1. 0 minus 2R1 to minus 2. R2 minus 2R1. 2 into 0, 0. 1 minus 0, 1. Into A. Similarly, you convert this 3 into 0. For that, R1 is R1 minus 3 or 2. Minus 3 or 2. You multiply elements of R2 by 3 and subtract from R1. R1 1 by 3 into R2. 3 0 is 0. 1 minus 0 is 1. R1 is 3. R2 multiplied by 3 is 3. 3 into 1 is 3. 3 minus 3 is 0. And second row is 0, 1. This is equal to, similarly, here also, you multiply R2 by 3 and subtract R1. R1 is 1. 1 into minus 3 into minus 3 minus 2 plus 6. 1 plus 6, 7 you have. Here, 7. 0. Minus 3 into R2 is minus 3. 0 minus 3 is minus 3. Minus 2, 1. Into A. Therefore, I equal to A inverse into A you have. Therefore, inverse of A, that is A inverse is 7 minus 3 minus 2 1. 7 minus 3 minus 2 1. This is the answer for inverse of the given matrix A. That's all about the problem 3. Using first problem I have solved using column operation. In the third problem I am using the row operation. So it is the method of finding the inverse of the matrix using row operation, the third problem. And one more problem I am going to solve now, that is your 10th problem, the exercise 10. What is the problem 10 in the exercise 3.4? Find the inverse of the given matrix tenth problem. Sorry, 12th one. I will solve 12th problem now. In the exercise problem number 12, find the inverse of A equal to, you consider the matrix A by 6 minus 3 minus 2 1. By the same rule, A equal to IA, you know. What is A? 6 minus 3 minus 2 1. This is A. And I is 1 0 0 1 into A. Here you convert the 6 by 1. For that you multiply the first, you divide this first row by 2. R1 is R1 divided by 2. You divide by 2 or multiply by 1 by 2. The elements of R1 are multiplied by 1 by 2 or divided by 2. 6 by 2 is 3. 3 divided by 3. R1 by 3. Because 6 and 3 are divided by 3 only. 6 divided by 3 is 2. And minus 3 divided by 3 is minus 1. Minus 2, 1. Similarly, first two elements are divided by 3. 1 by 3, 0 by 3 is 0, 0, 1 into A. The second step is add R1 is R1 plus R2. What is R1? 2 minus 1 plus R2. R1 plus R2 minus 2, 0. Minus 1 plus 1, 0. Minus 2, 1. This is our new matrix. And this is again equal to R1 plus R2. 1 by 3 plus 0, 1 by 3. 0 plus 1 is 1. 0, 1. Into A. Since all the elements in the first row are 0, the inverse does not exist for this problem. If in a matrix, if any elements of all the row or columns are 0, then the inverse of that matrix does not exist. That is the problem. See, since all the two elements in the row 1 are 0, since all the elements of R1 are 0, the given matrix does not, inverse does not exist for the given matrix. That is the problem. The solution for this problem is the inverse does not exist for the problem because all the elements in the first row are 0. Since all the elements in the first row are 0, the inverse does not exist. Does not exist. See, for this problem, inverse is not exist because all the elements of the first row are 0. Similarly, all the elements in the column are 0. In this case also the inverse does not exist. Therefore, this is the particular special problem. The inverse does not exist for this problem. Take down this problem. And I will stop here and I will continue in the next video with the remaining problems. Thank you.